Hello students, here I am continuing with program instructions. In the last two videos we have seen about load store instructions. In this video we are going to see about branch instructions. Okay, branch instructions are used to change the flow of execution, or it is used to call a subroutine. These branch instructions allows the program to have subroutines, if then else structure and loops. The change of execution, it makes the program counter to get the new address. That address is called target address. This ARM5 instructions are having some set of branch instruction that we can see here. So the instructions are branch, branch with the link, branch exchange with the link. Okay, these four instructions can have condition. So the condition is given inside this flower bracket. Then in the first two instruction we can see label. Label means direct address. Okay, so here address is directly present, target address is directly present in the instruction. In the third case, target address is indirectly present in the register. In the fourth case, the operand can be either label means address or register. Okay, so if the address is directly present in the instruction, that is called direct addressing mode. Indirectly present in the instruction means that is indirect addressing mode. Okay, so in the four instructions, the operand can be label, register, or label or register. If the instruction is branch, then program counter gets the address from the instruction, that is direct address from the instruction which is present in the instruction. Then if the instruction is branch with link, program counter will get the address from the instruction, and the link register will get the address of the next instruction after the BL instruction. Why we need this link register means, once the subroutine is completed, then the program will come back to the main program and it will continue the execution. For that, it should know the location where it left. So only the next instruction of branch instruction, the next instruction address will be saved in the link register. So once the subroutine gets over, PC will get the link register address, so that the program processor can come to the main program and it can continue the execution. So only we are saving the address of next instruction after the BL, after the branch instruction inside the link register. Then if the instruction is branch exchange, then PC will get RM, but it is not directly getting the RM value. One AND operation is taking place between the content of RM and 0xFF, and T will get RM logical AND of 1. T in the sense the thumb bit of CPSR register. Okay, then BLX, if the instruction is branch exchange with link, the operand can be either label or RM. If the operand is label, then PC will get that address, target address. T will be 1. If the operand is RM, then PC will get RM logical AND of 0xFF, and T will be RM logical AND of 1. Then as we have L here, link register will get the address of next instruction after the BLX instruction. Okay, we'll see the example. This first example shows forward and backward branch. You can see here B forward. Here the target address is given as forward. So for this instruction, the processor will skip these three instructions and it will directly jump to that forward location and it will execute the sub instruction. So it is skipping these three add instruction and it is executing the sub instruction. This is about forward. Then backward, see, we can see the branch here, B backward. Here the target address is backward address, target address is back address, so it will go to this back address and it will execute these three instructions. It is not moving forward, it is jumping backward and it is executing these three instructions. Okay, the next instruction, this instruction is written for BL, branch with link, BL subroutine. Here subroutine is a target. So after seeing this instruction, processor will skip these two next instructions. This it will skip compare, and it will also skip move equal. These two instructions will be skipped, and it will jump to subroutine, and it will execute the subroutine code. Subroutine code is a set of instructions, no? So once a subroutine instruction is completed, this instruction will be executed, means move PC comma LR. So we all know, as I said, for the branch with link, before jumping to the subroutine, processor will save the address of next instruction. Here the next instruction is compare. So this address of this compare instruction will be saved in the link register. So once the subroutine codes are over, this link register should be moved to PC. Okay. So PC, it got the address of compare instruction. So processor, for the next instruction, it will check the program counter. It will show the address of compare instruction. So processor will go here and it will execute the compare instruction. After the completion of compare instruction, then it will execute move instruction. Here in move instruction, we have condition equal. So in the compare, we are comparing R1 content and 5. If both are equal, then it executes the move instruction. If both R1 equal to 5, if these are equal, then only processor will execute this instruction. Okay. So this is about branch instruction. Thank you.